Good morning, or afternoon, as it were. Today we will be talking about making inferences from a random sample and a little bit about representative versus biased data. So take a look at this table right here. You don't have to write it down, but take a moment and if you need to, pause here and try to ask yourself which one of the vertical ones would be representative and which ones would be biased. So if I have too small a portion of the population surveyed, is that representative or biased? If I have a random sample, representative or biased? Questions that suggest a certain answer, representative or biased? And if the survey location doesn't represent the entire population, is that representative or biased? Take a moment. Okay, so if I have an insufficient population surveyed, like if I'm trying to figure out, oh, if I'm trying to figure out who most of the United States is going to vote for any federal office, and I only interview 10 people, that probably will not be representative of the several hundred million voters in the United States, so that one's going to be biased. If it's a completely random sample, well, it's still going to depend on some other things, but random sample definitely does help in it being representative. Now, question suggests a certain answer. Like if you say, if you're talking about two presidential candidates and you list only bad things about one and only good things about the other, and then ask them who they think they would rather vote for, that would be pretty biased. And now, if the survey location doesn't represent the population, so like if you're trying to figure out who the United States is going to vote for, but you only interview people in Hawaii, is that going to give you a good idea of the whole US? Probably not. What about just Hawaii and West Virginia? Well, that might get you closer, but still, probably not enough. You're probably going to have to interview a certain number of people from every single state, right? So we're going to have to say biased on that one too. So now our vocab for today is infer. Infer basically means, in math, predict based on sample results. Now there are a few things we need to be able to infer. We need to make sure that our sample was unbiased, that it was representative, and we'll need to use proportion. Now I'll go into detail on what proportion is. Make sure that you do write this vocab information. The proportion we'll talk about when we get to the example of it. So let's say, do not write this next part down. Don't write the stuff down that I'm going to put in orange. Need a darker shade of orange. There we go. Let's say across its factories in 1 year, Apple makes 1 million MacBook Pros. They test 100 of them, and 3 are defective. How many of the 1 million MacBook Pros are defective? So now because we said they looked across all their factories and picked out 100 of them, So this probably is representative of the whole population, the population being all of the 1 million MacBook Pros they made. It seems fairly unbiased. They're not saying, well, there are almost certain to be this many defective or anything like that. So they're asking an unbiased question. They seem to be using random sampling. So we can probably say this is a decent way to get a sample. Now, 100 is less than 1%, but it's as good as we're going to get for now. So think about that. The proportion of tested to defective is 100 to 3. What do you think is probably the proportion of all of the ones they made, the whole population, to defective? Technically speaking, the proportion is going to be the same because it's going to simplify to the same number. We're going to have to infer that 3,000 in total, no, I'm sorry, 30,000 MacBook Pros from that year are defective. Now I'm going to talk about two ways we could infer this. One way, and do write this one down. Write down what you're about to see in black. 3 over 100 is equal to x over 1 million. Well, the first thing I have to do is multiply both sides times 1 million. And when I do that, I will figure out that the millions cancel on this side, and 3 million over 100 is 30,000. 30,000 equals x. X was the number defective out of the total. That's the super mathy way of doing it. The other way of doing it is just to say basically what we set up here. 3 defective out of 100. How many defective out of 1 million? And with ones like this, you can sort of intuit it. You don't have to use the super numbery technique of turning it into a fraction or the like. You can sort of ask yourself, okay, if it's 3 out of 100, how many is it going to be out of 1 million? What number do I have to multiply 3 times? Oh, it's going to be the same number that I multiply 100 times to get a million, which in this case is 10,000. So we'd say 30,000 defective because 100 times 10,000 equals 1 million, and 3 times 10,000 equals 30,000. Now we're coming to another orange section. The orange means don't bother writing it down. If 3 out of 100 Apple MacBook Pros are defective, how many PCs can we infer are defective? The answer to this one is technically, we don't know. We don't know for 2 reasons. One, we tested Macs, not PCs. So it's a totally different population we're looking at. Now, the other reason that we don't know is because We didn't say how many PCs were produced. Even if this were the same population, we didn't say that how many we had in the first place. It could have been 1 million, just like the max, or it could have been 2 million, or something along those lines. Now I'm going to tell you one thing that is not going to be a textbook answer. In the textbook, the answer absolutely is we don't know, because we tested Macs, not PCs. Now, in the real world, outside of the textbook, the answer is still technically we don't know. That being said, in the real world, we're probably going to say, well, okay, while we officially don't know how many PCs are defective, we probably have sort of similar manufacturing processes between Mac and PC. They probably have a few software engineers that are the same people, so it's probably going to be similar to Mac. Again, that's real world. Textbook answer is, oh, different populations, done. No answer. All right, thank you.